If you ever have any Postgres difficulties, if you say the word Postgres 3 times, and I'm about to say Postgres one more time, and look what happened, I magically have Álvaro appearing. I learned that from Álvaro himself. If we're talking about wonderful community members and also talking about amazing sponsors that are involved in the Data on Kubernetes community, Andres and Álvaro are driving force behind that. When I got involved in the community, I literally, one of the first things I did, I started scrolling through the names of folks that were in there for Álvaro's good or bad luck. Since his name starts with A, he was at the top. I introduced myself and we hit it off immediately. Started to realize how much Álvaro can offer the community, which is exactly what he's been doing since then. He's joining us today. We did have planned to do a panel with Alexander Kukushkin, who's also a very good friend of Álvaro in the Postgres community. Unfortunately, Alexander is not able to join us. We hope everything's going okay with him, and sure we will be having him on in the future in a live stream. We had him last year talking about Zalando and Patroni, as his nickname is, Mr. Patroni. But anyway, today we'll be joined exclusively by Álvaro, so we have his full undivided attention. First thing that we got to get out there is big congratulations to Álvaro, who recently became a father. But that's not the only surprise he's going to be sharing us with us today. Álvaro, very nice to have you with us. How are you doing?
Thank you so much. I'm really flattered by your introduction, Bart.
Yes.
What can I say?
Yes. Jump right into it. You jump into your slides, and then Sylvain and I will be ready and waiting with questions asked to take this conversation further. But go for it. Tell us what the surprise is for today.
Okay. So yes, first of all, indeed, I became father a little bit more than 3 weeks ago already. It's been a real roller coaster. It's an amazing period of time, but it's also really hard. But anyway, I'm here virtually. I wish that's actually the only reason I'm not in LA today. But anyway, here I am virtually with all of you. So today we're gonna chat about Postgres and Kubernetes. This is gonna be like a live session. It's mostly unprepared, so you can shoot any question at me, Sylvain. I'll try to do my best. So moving on, I'd like to introduce today a very, very small surprise. But first of all, the compulsory slide about myself. So who am I? Álvaro Hernández, or Álvaro Hernández, if you pronounce in Spanish. I am the founder and CEO of Ongres. Ongres, by the way, means on Postgres, so it should be easy to understand what we do. Right? I've been myself using Postgres for a long time, more than 20 years. It's the only database that I've essentially used. And that's the only reason is because it's always fulfilled all my needs. So why look elsewhere, right? And I always try to look at innovative projects and go and behind and create them. So I've been working on projects like StackGres, which probably we'll talk briefly about it because it's Postgres on Kubernetes, ToroDB, which was a project open source also to move data from MongoDB to Postgres and create data tables dynamically. And I was also named in 2019 an Amazon Data Hero. So I'm here to answer any questions about Postgres, but also databases in general, whatever I can do about cloud and whatnot. So let's move on to this small announcement that I have for you today. And is that this open source project, we've been working for more than 2 years already. It's called StackGres, and StackGres is a whole stack of components around Postgres to run Postgres on Kubernetes. So we are at stage 1.00 release candidate 1, which means we're almost there to release the final GA version of StackGres and announce it to the world. So this is a premiere. I'm very happy to be able to stay today at this Day OK Day and say, hey, there's StackGres. Go to stackgres.io, give it a try, give us the latest bit of feedback before we announce it publicly. And please share with your feedback with us. Just 1 minute, let me move on to what is a StackGres so that you understand what it is. But it's basically an operator and a Postgres platform on Kubernetes for innovation. So we want to keep Postgres as a core, and databases need to be boring. Postgres is boring, and we want to keep it that way. But around it, we can construct and build these innovative features. So let me just point to very briefly to 4 of them. First one is extensions. Everybody loves Postgres extensions. It's what allows you to do really cool things with Postgres. So we have focused so much on extensions. That is the platform with more extensions available in the world. There's more than 120 extensions, and this number is going to be growing over time to reach hundreds of extensions. There's nothing like this. Also, we have developed together with the Envoy community the first Envoy filter for Postgres. Which is a Postgres that intercepts the Postgres protocol and allows us to do 2 really cool things. One is to provide additional metrics without having to touch or query Postgres, and the second one is to terminate SSL. So we don't need to go to Postgres to do SSL. There's also a fully featured web console, has even dark mode, so everything you can do either from command line or the web console. And last but not least, we can collect both Postgres and Patroni logs because StackGres uses Patroni, thanks Mr. Patroni, even though you're not here with us today. And they are collected into a single location, a central location. So you don't need to go and kubectl exec or to all the pods. And this central location is yet another Postgres database with one extension, timescale for time series data. So we can collect a huge amount of logs and process them. So you can query logs with SQL or the web console. So I hope that these 4 very innovative features are at least a reason for you to give it a try and check it out on stackgres.io. And last but not least, I would like to show you and explain, moving on, that tomorrow, if you are especially interested in the extensions, let's please move on to a small announcement that I'm going to be giving tomorrow another talk at Kubecon, which is specifically explaining about how we did these Postgres extensions. It's very interesting, first of all, because it's the only Postgres talk in this KubeCon, also in the last, several KubeCons. And second, because we developed a mechanism for loading dynamically extensions into the containers, because extensions are code that you load dynamically, but containers are built from images that are immutable. So we had to do something there to solve this problem. I'll be explaining in my talk today at 5:25 p.m. Pacific time. So please join me if you want and can do that. And that's all I wanted to say. Now I think I'm ready to be shot any question.
All right. Can we get back? So while you were talking, Álvaro, Sylvain and I were playing Postgres, the drinking game. And so every time you say the word Postgres, we had to drink. Needless to say, that was a very intense few minutes. But no, awesome. It's very, very clear Álvaro is a strong authority on Postgres. I even want to get into another spoiler because I saw this recently on Twitter. Álvaro, are you going to be doing a conference in Ibiza in Spain in next summer, perhaps?
And yes, you're absolutely right.
Yeah, so we got that to look forward to. Like I said, if you have anything about Postgres related, jump into our Slack. And Álvaro, he's also very, very good at answering questions. That's exactly what we're going to do here. In that event, do you think we'll be able to talk about data on Kubernetes?
Yeah, absolutely. It's going to be a must. So we organized this conference for the first time in 2019. 2020 and 2021 was stopped for obvious reasons. But we're coming back on 2022. Go to pgivz.io or look for Postgres Ibiza. And, it's a conference where you can go to the beach, swim, and then go back to the next talk. It can't get better than that.
Anyway, I'm already looking at flights, and my partner's quite excited about it too. Sylvain is also invited. But now we want to jump into some more Postgres related questions. But looking at your experience, because this is something we talked about a lot, and what Sylvain mentioned earlier in his interview that he did with Otter from DreamWorks is this kind of, okay, how do we make running data on Kubernetes look like something that's not so foreign, that's not so strange to a lot of folks that, let's say, have been working with databases for quite some time. And I've seen this with friends of mine that have, done the whole big data stack, have been working with data for a long time. You say, hey, what about data on Kubernetes? They're like, no, way, that's too hard. In your experience, what was your first experience like with that? And based on that, what recommendations would you make to folks that are out there that are starting to work with, that are starting to think about running databases on Kubernetes? What are some things that maybe you would like to share with them so that it's not such a rocky road when they get started?
Okay, so actually, let me briefly tell you a story of how we went to Kubernetes. It's not because we decided, we want to, Kubernetes is the next fancy thing and we need to be on Kubernetes, or because, whatever reason. No, the reason why we came to Kubernetes is because of its API and the automation. Basically, we've been working, if you look at Postgres is something that requires a whole stack of components around it. It's not that you apt-get install Postgres and you deploy this to production. You deploy this to your laptop, but you will not run this in production. You typically want to add a connection pooling, monitoring, backups, management of logs, high availability, and all these components, they don't come with Postgres. Postgres is kind of if you can call it like a Linux kernel. We need a distribution to run this in production. So where do you take all these components from the ecosystem? How do you make them all work together? This is a difficult problem because it depends on many environments. So if you have the networking with a load balancer, or you have like a virtual IP, or you have a DNS, then the entry point is going to be different. And then if you look at the storage, whether it's going to be a NAS or a SAN or a cloud, a native volume, everything is going to be different. So when we were looking that, we were repeating Ansibles and chefs and puppets and all these things in every customer, a different environment, different ways. We asked ourselves, is there any way in which we could create a single deployable package for all environments? And the answer was Kubernetes is the only answer to this problem, thanks to its API. So there's a very good reason to run databases on Kubernetes because it's standardizing the environment below, which otherwise can be too complicated. So you're really, really saving a lot of time and effort by working on Kubernetes. But also, and contrary to some beliefs, your availability, which is a critical concern for many, can be increased in Kubernetes. Some people fear that things in Kubernetes vanish away. Well, they don't. Running containers are basically wrappers around processes. If your processes run well, your containers are going to be still there. They just don't vanish, right? There's certain situations in which a Kubernetes orchestrator may reschedule them, but it's easy to protect against those arbitrary situations. But because of the rehealing characteristics of Kubernetes and stateful sets, for example, it's actually trivial on Kubernetes that if a node fails, it will be restarted and the pod rescheduled somewhere else. And then with tools like Patroni to readjust the cluster so that there will be a failover if required, that the next node will connect to the previous one, and the cluster will be rehealed. This is not so much easy on other environments. And most of the environments that we see, maybe they have high availability, but they don't have auto rehealing of nodes. So if a node dies, you're with one node less. And this doesn't happen on Kubernetes. So it actually can lead to higher high availability. So I think it's a really good thing in general.
Very, very good. I think Sylvain's already thinking about stuff he wants to write based on your answer, but I'll let him take the next question. So Sylvain, if you want to jump in, push the button.
All right, thanks, Bart. So maybe something interesting you could go over, Álvaro, is the history of stateful workload on Kubernetes. It not has been always like an easy thing to do. So could you go over kind of the how the timeline of different concepts that came and disappeared? And
yeah, absolutely. And this is actually one of the areas where people show concern about Kubernetes, is because of how it was in the past. We need to understand that Kubernetes has evolved fast and well. But it's been a changing landscape. So what was true 4 or 5 years ago may not be true today. Most likely it isn't, right? So what do you do when you want to run a stateful workload like a database on Kubernetes? First of all, you could use the storage within the container, this ephemeral storage. But that's probably a pretty bad idea, right? But first of all, because it is ephemeral, its lifetime is tied to the container, and second, it's very slow because it goes through some kind of, let's call it emulation. And so if for anyone who has tried this, that will get bad results. Then, so on Kubernetes, there was this need to have storage, and because ephemeral container storage was not appropriate, there was a first story called pet sets that appeared in Kubernetes. It was good because it laid the foundation to the next one, but by itself had significant problems in many areas. So pet sets actually gave a little bit of bad fame for running stateful workloads on Kubernetes. But this has moved on, and all the problems that pet sets had have been solved in stateful sets, which is kind of the next generation storage management in Kubernetes. And it's not the only option. The key in Kubernetes right now is that you have the ability to create persistent volumes, which are managed by their handles called persistent volume claims. And this allows they're an abstraction of the storage, and the storage can be redundant and external to the container. It's external to the containers and can be redundant, can be cloud volumes, for example, or can be container attached storage, software defined, that could also be redundant enough. But because it is external to the container, it's not tied to the lifetime of the container, and there's no performance hit because it's just mounted as a file system inside of the container. So as of today, most operations for data on Kubernetes, they use stateful sets, which is a higher level abstraction that manages the volumes for you, the persistent volumes and the claims, and is able to understand that you're running potentially a cluster of several instances. But there's even the option of just managing the persistent volumes and persistent volume claims by yourself. I know a few operators that actually do this, which means they don't use stateful sets. But they have the equivalent notion of a stateful set implemented as part of the operator. Both approaches are potentially good and correct. The key is that we moved on from persistent pet sets to persistent volumes, which are external storage to the containers. And this actually brings enough reliability and tolerance to what you want to running data on Kubernetes, essentially.
Yeah, and actually, so yeah, historically, like it was a risky thing, and pet set were part of the reason why running stateful workload on Kubernetes was not really a thing, but that has really shifted. And as we can actually see that, we surveyed 500 organizations, asking them about their stateful workload in Kubernetes, and 90% of the respondents believe that Kubernetes is ready to run production stateful workload on Kubernetes. So I think that this belief that Kubernetes is only for stateless workload is kind of gone, or at least going away, according to that. So it's great. Like, so, you know, like I think we got to a point where Kubernetes has like the basics to host this. How do you go about managing the day two operation once you have set up your stateful workload in Kubernetes? What are the tools available to users?
Yeah, actually, day two operations are, in my opinion, one of the other reasons to go data on Kubernetes. Specifically talking about Postgres. Postgres is a database that is actually complex to use in production. Again, looks simple to deploy, and it looks also simple to operate until you go to certain volume of operations and you start realizing that the database requires some maintenance operations. It requires vacuums to clean the bloat. It requires reindexing because your indexes became bloated and they start responding slow. You need some kind of tuning. You obviously need backups. You need sometimes repack operation, which is to remove this bloat, and many others, right? And these operations are something that needs to be run by humans, but by DBAs. Not even on the cloud managed environments, these operations are present. So it's on you, basically. And in reality, these operations, even though they require a lot of domain knowledge expertise, the execution of those is potentially like a not so very complicated runbook, which means that there was an opportunity for automating them. And again, thanks to Kubernetes API and all the automation that is built in, this is possible to do from an operator perspective. So operators can leverage this Kubernetes API and bring this domain knowledge expertise of running day two operations, normally called in databases DBA maintenance tasks, as fully automated operations. And then you're really not only saving a lot of time and effort into not having to run those manually, but also you're running them error-free because they're already programmed and correct, right? This is something, I don't want to piggyback too much on this project that I just mentioned before in StackGres, but we have done this. I'm speaking by experience, right? Speaking of Postgres, we have automated vacuum, reindex, repack, minor and major version upgrades, and even benchmarks. So you can just specify a simple YAML file and run a benchmark and then collect the results as part of the status of the CRD. And this is just examples of how you can leverage automation in Kubernetes for simplifying running your database in Kubernetes. This is something that's really hard to do. You need custom software developed for running this outside of Kubernetes. And I haven't seen it before this.
Yeah, so we actually saw this in the report where the more organizations are running stateful workload on Kubernetes, the more productivity boost they get. Organizations that host more than 75% of their production workload on Kubernetes report being twice as productive as before. But on the other flip of the coin, and so operator enable that, but on the other flip of the coin, for organizations who are not running their stateful workload on Kubernetes, operator were mentioned as the top barrier. And if we dig down into that, the two main issues are the varying different level of quality and also the lack of standard. So what do you have to say about this? Like, how do you think we could have better standard for operators?
Yeah, it's a hard problem. Right now in the Postgres world, there are close to 10 operators. Maybe I'm even missing some. Not all of them are very well known. I can try to recap mentally, but around 10 operators for sure. Let me know if you want me to try to recap all of them. So which one is best, or which one is a better fit for my use case? It is a difficult question to answer, right? So, but this is also, speaking of Postgres specifically, this is a well-known problem. Postgres ecosystem has created many tools for the same tasks. So it is just by experience where people are learning which tools are best for which use cases. I don't know how we can assess better the quality or maturity of operators. There's this famous 5 levels of maturity and capabilities developed by Red Hat. But to be honest, everybody claims that they achieve mostly all of them, right, without further ado. So I don't think that's very reliable mechanism to assess quality. But I have some thoughts about the standardization, the second part of your question. So what is an operator? An operator is a development pattern for creating software on Kubernetes, which essentially consists on 2 parts. One is a CRD, or a custom resource definition, which is essentially a custom object you create on Kubernetes, and a controller, which is a daemon or a server that runs inside Kubernetes that speaks to Kubernetes and reacts to changes on these CRDs. On the controller part, there could be many implementations. But let's look at the CRD part, this custom resource definition. Again, what is it? A custom resource definition is a way to convey your domain level expertise into a custom object, which can have the properties that you want. If they are properly designed, these CRDs can have very high level properties of what you want to achieve, so that the user, A, doesn't need to be an expert on the subject matter, and it is declarative. Let me give you an example. This is something we have also tried to achieve on StackGres. And if you look at the CRDs, this YAML to create a cluster, they don't ask you for any specific Postgres knowledge or expertise. You talk about the number of instances, the Postgres version that you want to be instantiated, about if you want to reference a Postgres configuration, just provide the name, about obviously the disk space, about the kind of instance that you want, if you want monitoring or not. But it's nothing is like super low level, or what is going to be this Patroni configuration parameter so that the replication works, right? So they're hiding, the goal is to hide all this complexity. Okay, now every operator has created their own CRDs with their own shape. Some of them more high level, some of them less high level. How we can collaborate, how we can standardize? We could standardize on the CRDs. If instead of looking these CRDs to be so tightly coupled with their own controllers as part of each operator, if we look at them as if they were specs, like specification, if we could gather together and create like a committee and say, okay, a user wants to create a Postgres cluster. Every Postgres operator has a Postgres cluster CRD. Others have others, they're just one, but everybody has a cluster with different name, but everybody has a cluster. Well, then why don't we sit together and create specification with many optional fields if needed to say what is the cluster expectation of a user, what does the user need to provide in order to create a cluster? What is the expectation? This. And then with some compulsory fields, with some optional fields, potentially even some extensions or proprietary extensions. But that's a way where we could standardize by standardizing on the CRDs. Let me give you another example. Let's look at object storage, or cloud storage, S3, or Google Cloud Storage, or Surblog, or whatever, MinIO. There's many operators which are storing data on these buckets. And each one of those, if you want to store data on a bucket, you need to provide a reference to it. So probably you'll provide the endpoint, the access credentials, the path within the bucket, and maybe a few other options. Why don't we standardize on those? Because I've seen so many implementations already of the really same thing, a reference to an S3 bucket. So why don't we as a community sit down, create committees, and well, committees. I don't want to make it very formal, but conceptually, and standardize on CRDs. Then anyone can provide their own implementation, and you can choose to implement this feature or not. That's up to you. But then users would be able to more easily port and move away from one operator to another.
Thanks, Álvaro. That was a very detailed answer, and really appreciate your thought on that. Actually, if some of you in the audience have an opinion about how to make operators better or come up with a standard, we, the Data on Kubernetes community, will organize working groups to discuss this type of question and try to come up with ideas and suggestions, and then involve the broader Kubernetes community. So we will be sharing about those shortly, but join our Slack, and hopefully we can see you there. So taking a step back, as you said, Postgres is not fancy, but that's also why it's great, is that it just works, right?
Yeah.
And but Kubernetes also offers different technical paradigms that were not accessible to us prior. And so what are your thoughts on what's next for databases when they're hosted on Kubernetes? Are there new paradigms? Are there new possibilities coming up that some company or some open source project are already offering, or that are to come?
Yeah, so that's a very interesting question. There are some databases who claim to be cloud native, and for the most part, I agree with that definition. The main difference for these new databases compared to more classical databases is potentially the replication architecture. So Postgres works on a primary replicas architecture. You have a single read-write node and multiple read-only nodes potentially. Whereas other databases may offer an architecture where you have multiple write nodes. That's absolutely fine, and that's something always desirable in principle, but it's not that much needed in the case of Postgres. So it's an advantage, but I wouldn't say this is a reason to rewrite Postgres from scratch and build it in this cloud native way. Actually, building a database, it is a quite complicated thing. There is a quote by MongoDB's CEO that said, a little bit shooting himself in the feet some years ago, that taking a database to a point where it's mature enough to run in production takes a decade. And they were like 5 or 6 years old. So okay, we'll wait 4 years, right? But it's a good point that also Oracle, I don't know who exactly, but someone at Oracle said the same stuff, right? Like a database takes 10 years to mature. I don't disagree significantly with this. So is it justifiable right now to say, okay, we love Postgres, but let's rewrite Postgres in a cloud native way? Okay, then wait 10 years until people are going to run this in production. So instead of kind of thinking of a whole rewrite or redoing things, I'm more prone to look at databases like Postgres, and instead of reinventing them completely, try to look at them. I consider Postgres a little bit of a monolith. I don't say this in a bad way, but it does a lot of things. Now, if you look at the Kubernetes world, at the CNCF ecosystem, there's many other components that could take and replace some of the functionality that Postgres does. For example, I just mentioned it before, but this Envoy, the Envoy proxy, has a Postgres filter that we helped develop. And this Postgres filter is able to terminate SSL, Postgres SSL. So instead of letting Postgres terminate SSL, you can remove all this SSL code from Postgres and let it do at the Envoy side. The advantage is that Envoy has APIs for managing configuration, already connects to things like Cert Manager. And so you can use a tool that is normal and usual for Kubernetes users to manage the certificates like Cert Manager or others. And then you don't need to A, learn Postgres specifics, and B, you relieve Postgres from this workload and can focus on other workloads. Can use the CPU for other stuff. This is just one example. If we start looking, we could make dents on the functionality of core Postgres and take it away and replace it by native components of the CNCF ecosystem. For example, another example is log management. Log management is something that we have accomplished by using FluentBit and FluentD. Postgres supports syslogs, supports CSV logging, supports a lot of logging mechanism. All of those, for the most part, can be replaced by FluentD and FluentBit. Monitoring is more or less nowadays integrated with Prometheus, but there's still a lot of work to be done. There's no integration with OpenTelemetry. The same. There's no tracing in Postgres. There's actually tracing in Postgres, but not the way we know it in the Kubernetes world. And this is also something that could be built into Postgres or stripped off Postgres into external components. That's how I would reshape databases for working Kubernetes nowadays.
Okay, very, very good. And we're almost out of time, but just one last question. Sylvain asked us earlier to the speaker we had from DreamWorks. Someone gives you, Álvaro, a magic wand to make the process of running stateful workloads on Kubernetes easier. What are you going to do with that wand? Or that you got a wish to make to say that I would like to change this. It could be something in a technical sense. It could be something in a mentality sense. But what needs to happen in order to take the next step forward?
Actually, to me, it's just, I talked before about the CRDs, to really make the CRDs super high level, super easy to use, that they don't convey any low level knowledge. This doesn't require any magic, just a little bit of a thoughtful process on the people who are creating the operators to make them really easy to use, and that they don't require expertise on the database that you're running. So that if you're a Kubernetes administrator, you don't even need a CKA. You should be able to deploy a Postgres cluster, MySQL cluster, Cassandra cluster. I think that should be enough.
Yeah. So let's reduce the fear factor as we get closer to Halloween. Let's get brave and not worry about that. You've said also on previous occasions that CRD is your favorite feature, so it's no surprise that you've stuck with that. No, but it's a good thing. Not everybody likes to use the word favorite because then things start getting into heated debates. But I think that's a really, really good point is let's make it more high level, more accessible. So folks that have the experience, have the know-how, have overcome other technical challenges. Let's get them in there. And so I think that's going to be a focal point then in our community is let's drive more attention to CRDs so that folks that are, maybe a little bit behind or just catching on to this trend of running stateful workloads on Kubernetes, that can be simpler for them and give them more probabilities of success.